So I'll explain how to multiply matrices together. Let's say I have two column matrices. So let C be this column matrix and let K be this column matrix. I'll define this. If I write C and then K and then I put an arrow inside of parentheses between them, then I just mean you slam these two columns together. So just slam this column into that one. So you just multiply directly across. You'll get this new column. If I put two sets of parentheses here, then that means to add the results in this column. Here's an example. So if I take this column and I want to slam it into that column, I'll just multiply straight across. So this will be 28, this will be negative 15, and this will be 20. So you get this new column. If I put two sets of parentheses here, then you add the results of this column. So this will be 28 plus negative 15 plus 20, and that'll be 33. So if I just have one set of parentheses, that means you slam these columns into each other. That'll give you this new column. If I have two sets of parentheses, that means you slam them and then you add the results of this column, and that'll give you 33 here. Here's how we define multiplication of matrices. So let A be a matrix with the size MA in A. So this is the number of rows of A, and this is the number of columns of A. Let's say B is a matrix that has this many rows and this many columns. If the number of columns of A is the same as the number of rows of B, then you could define A times B to be the matrix with this new size. So it's the outside numbers here, the number of rows of A and the number of columns of B. So these two numbers here have to be the same, and then the size of the new matrix will be obtained from these two numbers. To get the entry ij of this A times B, you'll take the ith row of A, you'll flip it, so I take the transpose here, you'll slam it into the jth column of B, and you'll add the results. So I'll show you an example of that now. Here's an example. Let's say A is this matrix 1, 2, 3, 4, 5, 6, and B is this matrix 7, 8, 9, 10, 11, 12. I want to multiply these matrices together. So look at the size of A. A is a 2 by 3 matrix. You look at the size of B. B is a 3 by 2 matrix. These numbers here match up, so these inside numbers match up, and that means you can actually multiply A and B. And the size of this new matrix, A times B, will be what you get from these outside numbers. So it'll be a 2 by 2 matrix. So to actually find this matrix A times B, we'll have to find each entry of that matrix. So in general, if you want to find entry ij of this matrix A times B, you'll take the ith row of A, you'll flip it to be vertical, and you'll slam that into the jth column of B. Then you'll add the results. Here's what it looks like. So I'm trying to take this matrix times that matrix. I want to obtain this entry here. So you look at where this entry is. This is in the first row and the first column. So since this entry that I want is in the first row and the first column, I'm going to take the first row here, times the first column. So you're going to take the first row of A, you're going to transpose that. So if you take this row and transpose it, you'll get 1, 2, 3. I'm going to slam that into the first column of B. Here's the first column of B. So you took this first row of A, I'm going to slam it into this first column of B, and I'll add the results. This will be 58. So now I know that when you multiply these two matrices, you'll have a 58 here. Now let's find this entry. So look at where this entry is. This is in the first row and the second column. So I'm going to take the first row here times the second column here. So here's the first row. I just transposed it. I'm going to slam it into the second column. So you'll slam these and then add the results. That'll give you 64. So I know that this entry here should be 64. Now I want to find this entry. This is in the second row and the first column. So we're going to take the second row here times the first column. So here's the second row, and then here's the first column. So you slam and add these together. That'll give you 139. So there should be a 139 here. Now I want to find this last entry. So you look at where this entry is. This is in the second row and the second column. So we're going to take the second row here times the second column. So here's the second row, and here's the second column. You're going to slam and add these together. That'll give you 154. Okay. So it's 154. So here's what you get if you multiply these two matrices. So remember, you can only multiply matrices when the number of columns here matches the number of rows here. So you need the number of columns from this first matrix to be the same as the number of rows of the second matrix. You can see here that the number of columns is 3 and the number of rows is 2. So you're not going to be able to multiply these two matrices. If you actually try to do it, then you'll see that when you flip these rows to be vertical, they won't match up with these columns. So you need to be able to take this row, flip it vertically, and then it should match up with these columns. That's not the case here, so you can't multiply these matrices. Now I want to say a little bit about matrix inverses. So let's say that you've got a matrix A. It's an n by n matrix made of real numbers. We'll say that A is invertible if there's another matrix B where A times B gives you this identity matrix. So again, let's say A is an n by n matrix made of real numbers. If A is invertible, then we'll define the inverse of A to be this matrix B. So we'll call that the inverse of A. So the inverse of A is just a matrix that when you multiply it by A, it gives you this identity matrix. Here's an example. Let's say A is this matrix 1, 2, 3, 4, and B is this matrix -2, 1, 3 halves, -1 half. If you multiply these two matrices, you'll get this identity matrix. And that means that A is invertible, and the inverse of A is this matrix here, because when you multiply these two matrices, it gives you the identity matrix. So you would call this matrix the inverse of A. You can find the inverse of a matrix using row reduction. Let's say that A is an n by n matrix made of real numbers. If you want to find the inverse of A, then you could do this. So you're going to write down this matrix that you get by gluing the identity matrix onto A. Then you could find the row reduced echelon form of that new matrix. If that row reduced echelon form looks like this, so you have the identity matrix on the left now, and then some other matrix B on the right, then your inverse of A is this matrix B that you see on the right. If the row reduced echelon form of A with the identity matrix tacked on, if you row reduce this and you get some matrix CD where this C is not the identity matrix, then A is not invertible and it won't have an inverse. So again, if you want to find the inverse of A, you'll write down this matrix here, just tack the identity matrix onto A. You'll row reduce that matrix, so you're going to find the row reduced echelon form of this matrix. If the row reduced echelon form looks like this, so if you see the identity matrix on the left, then your inverse will be this matrix on the right. If this row reduced echelon form doesn't have the identity matrix on the left, then you have no inverse. Here's an example. Let's say A is this matrix 2, 1, 0, -1, 0, 1, 0, 1, 1. I want to find the inverse of this matrix. So all I'm going to do is tack the identity matrix onto the right here. So here's A with the identity matrix tacked on. Now you're going to row reduce this whole thing. So if you row reduce that whole thing, you'll get this. And you see the identity matrix on the left. So this matrix on the right must be my inverse. So the inverse of this matrix would be this matrix here. Here's another example. Let's say A is this matrix, and I want to find the inverse of A. So we're just going to tack the identity matrix onto the right. Here's what you get when you tack the identity matrix on. Now we're going to row reduce this whole thing. So you row reduce this, and you see that you're not going to get the identity matrix on the left. So this original matrix A has no inverse. So A does not have an inverse. Let's define determinants of 2 by 2 matrices. So if you've got a 2 by 2 matrix, so it looks like this, A, B, C, D. If you want the determinant of that matrix, that's defined as A times D minus C times B. Here's an example. If A is 1, 2, 3, 4, then to get the determinant of that matrix, you take 1 times 4 minus 3 times 2. So that'll give you 4 minus 6, and that'll be -2.